Okay, guys, thank you very much for joining this session today. Remember, we're going to discuss how are you guys going to attack your June exam. So to prepare for your June exam, some of you are writing exam now on this coming Friday. So we're going to start with Newton's law. Hopefully by Thursday, we'll be doing electrostatics. For those who are doing electrostatics, if you've already did electricity, will cover everything. Don't worry, guys. So I want us to do this paper. I'm just going to share the paper with you guys now. Okay, I will share. Okay. Okay, I'm going to open the paper now. Please give me a second. Okay, this is the question paper that we're going to do. June exam, grade 11 physics. Right, I'm going to share the screen now. Can you guys please confirm if you can see the screen?
Yes, sir.
Thank you very much, Yuhan.
Yes,
Thank you.
Yes, sir.
Thanks. So this is the question paper that we're going to cover today, guys, for your June exam preparation. I'm going to start with Newton's law. We're going to start with this. I don't want us to, okay, let's start with this. Maybe we can just skip question 2 because this is not something that you can expect in your June exam. Please trust me, guys. But the question 3, this is something that you can expect. So I want us to focus more on the questions that there's 80% chance that you'll get them in an exam. So we're going to start with this question where they want you to say, Snetemba, can you please read the statement for us, please?
All right, sir. A 5 kg trolley is at rest on a rough inclined surface, which makes an angle of 30 degrees with the horizontal. A constant force is applied, causing the trolley to accelerate up the incline for 2 meters at 0.45 meters per second squared. Ignore the rotational effects of the wheels and air friction.
Thank you very much. Hopefully everyone was also reading that statement. So we have a 5 kg trolley that is on rest on a rough inclined surface. So when I have something like this, I know that the first question they will want me to define Newton's law. So if they say state Newton's second law, this tells you that the question is based on Newton's second law. The following questions are based on Newton's second law. So which makes an angle of 30 with the incline or with the horizontal. And now we have the constant force that is applied. And this constant force, it caused the trolley to accelerate up the incline, and we are given the acceleration, they say for 2 meters. So the distance is 2 meters and the acceleration is 0.45. So I'm going to first, in order for you to, I know this is grade 11, please answer 3.1 on your own. Make sure that you use the exam guideline to state the Newton second law. So when you state the Newton second law, some of you can also say when a net force acts on an object, the object accelerates what? In the direction of the force. But if you just if you only give us that statement, it's incomplete. Make sure that you also state that the acceleration is what? Is directly proportional to the force, and it's inversely proportional to the mass of the object. So my main, guys, these are some of the marks that we can't lose. These 2 marks, the 3.1 and the 3.2. This is our 6th mark, and we need to make sure that we collect those marks. So Newton's law is something that we're going to get. Now let's talk about drawing a label free body diagram where we're going to show all the forces that are acting on a diagram. So let me quickly go back this side so that I can see you guys. Can someone tell me how many forces do we have on that diagram? Let's quickly go back to the diagram. How many forces are acting on this diagram? Can someone tell us, please? Anyone? How many forces are acting on the diagram?
So we have 4 forces.
4 forces, okay? So now when you say we have 4 forces, can you please tell me those forces?
We have normal force.
Okay, so I'm just going to quickly, okay, it's fine. Wait. You said we have the normal force. We know that the normal force always, it is perpendicular to what? The normal force, it is always perpendicular to the surface. So this tells us that, please guys, give me a second. I forgot to connect my SP pen. Okay, 1 second. Okay, so now this is what okay, so remember that we'll have the normal force that will always be perpendicular, right? So the normal force will always act in that direction. So this is our Fn. So what else do we have, Sinetemba?
We have force applied.
Okay, and the force applied is going up. Then we have the force applied.
We have the FG perpendicular.
Okay, let's not put the perpendicular components. Instead of FG, can we just write the weight?
Okay.
Then we have FG. The last one is
frictional force.
Frictional force, which is going in an opposite direction. So this is FF. So now this tells you that you to answer the 4.3. So to answer 4.3, I'm going to say that this is the answer for 3.2. Right. Okay. Let's take this thing step by step because we have a lot of time today. We started exactly on time. So now this is 3.2. So to answer that, to draw the free body diagram, I'm going to say that I have the force applied. Wait, guys. I think if we can go back, okay, we have the force applied. Okay, yes. We have the force applied. I'm just gonna call that F. Then now we said we have FG going down. That is our FG. Then this side we have the frictional force. So we can call it FF. Then we have F that is perpendicular, like that, which is the normal force. So by doing that free body diagram, you'll collect 4 marks. Let us quickly go to the next question, which says, this is 3.3. Listen to 3.3. If it is given that the coefficient of the kinetic friction along the inclined UK is 0.18. So you are given the coefficient of friction and they want you to calculate what? They want you to calculate the frictional force of the trolley as it moves up. Okay, first thing first, you know what I'm going to do? I'm going to say that this is how I'm going to answer this question for the question 3.3. Right. So to answer question 3.3, right? I'm sorry. Guys. Okay. Sorry guys. Okay. So this one is 3.1. Right. So on this 3.31, we're going to say that, okay, we know that this force is what? The force that they are asking for is the force, they want us to find the frictional force of the trolley for 3 marks. And to find the frictional force, this is what I'm going to do. First thing first, I know that this thing is moving. It has a kinetic friction. And what is the formula for kinetic friction? The formula for kinetic friction will be
UK multiplied by normal force.
Exactly. So it will be F. We're going to say Fk. It's equals to the UK multiplied by the normal force. So guys, we are given the UK. So the UK is given. Remember that we are given the coefficient of kinetic friction, and they said this is 0.18. Okay, we are happy with that. But what about the normal force? What is the normal force equals to? So to answer 3.3.1, you need to calculate the normal force. Right.
Yes.
You need to calculate the normal force. Remember that the normal force is equal to the FG perpendicular, because this thing is on inclined.
Yes, sir.
Right. It's equal to the FG perpendicular. So I'm going to indicate that so that everyone can see why is the normal force equals to the FG perpendicular. Then maybe we can go more into this part. So remember, if I have a diagram like this, if I have a diagram that is on horizontal, if I have a box that is on horizontal like this, the normal force will be equal to Fg, right? It is just equal to the weight. Therefore, I can say that the normal force is equal to the weight, which is Fg, which will be mg. But when it is on inclined, the normal force is equal to what? When it is on inclined, when it is like this, where I'm going to have this as theta, therefore it's something like this. Therefore, this is the normal force. So the normal force is equal to this force, the Fg perpendicular. And we know that the Fg perpendicular is equal to the mg, the cos of theta. Right. So now, guys, this is what I want you to know on this session. I need you guys to always remember that the Fg parallel, it's equal to mg, the sine of theta. Then we have the Fg perpendicular, which is equal to mg, the cos of theta. So let's go back to our question. So if we can go back to answer our question says calculate the normal force. And remember, we said that to calculate 3.3.1, we said Fk is equals to the UK multiplied by the normal force. And we know that normal force is equals to Fg perpendicular. So Fk will be equals to the UK, where there's normal force, I'm going to put mg, the cos of theta. Right. So I just have to substitute what I'm given. Therefore, the frictional force will be equal to the UK was given as 1.8. Let's go back to the diagram. The UK, remember the UK is given as 0.18. Right. The UK is given as 0.18 and the mass is 5. So the mass is 5. Therefore, G is what? G is 9.8. Right, which is the gravitational force. Therefore, I'll have this as the cos of theta, and the angle is given as 30 degrees. Right, the angle is 30. So what I'm going to do, I'm going to say this is 30 degrees. So now I need someone to do what? Someone to assist us with the calculator. Tell us what is the product of 0, 1, 8, 5, 9.8, and the cos 30. What do you get when you multiply those numbers?
7.64 newtons.
7.64 newtons. Thank you very much. 7.64 newtons. Right. 7.64 newtons. So now let's talk about, remember, it's very important when we are preparing for June exams. We also talk about how they mark this question so that you don't miss any mark. You're going to get a mark for changing, so for saying that the normal force is equal to Fg perpendicular, which is equal to mg, the cos of theta. There's 1 mark for that. Then you're going to get another mark for the correct substitution. Then there's a mark for the final, there's a mark for the final answer.